Alright, so in this problem, solving this by the quadratic formula is honestly not the best method. I want to just show you, if you have 12x squared plus 10 equals 0, what's the best way? There's no x term, right? So we could take 12x squared minus 10, divide by 12, and x squared equals what? Negative 5 over 2 goes in that 5, 2 goes in negative 5, 6. So take the square root of both sides. That is the easiest way to do this problem. But that being said, they didn't ask us to solve by taking the square root. What did they ask us to do? To use the quadratic formula. So there is no x term. So since there's no x term, we make b equal to 0. So a is 12, b is 0, and c is 10. All right, so now the next step is to write our formula. X, the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. I substitute what I know. So x equals minus 0 plus or minus the square root of 0 squared minus 4 times 12 times 10, and then all over 2 times 12. Okay, so then I always like to simplify this. So then we're going to end up getting x equals the square root of 480. Oh, let me rewrite that. 480 divided by 24. Okay, and this is plus or minus, right? Now, hopefully you're looking at this and going, hey, we've got to simplify this. This square root of 480 is a really big number. And this is the hard part. So there's a lot of different ways to simplify the square root of 480. I'm going to use the same technique I've been using, and you'll see why it's not necessarily the best way to do it, but you will understand what I'm doing. So 1 times 480, 2 times 240. 480 divided by 3 is 160. 4 goes into that 120. 5 goes into it 96. 480 divided by 6 is 80. 487 doesn't go into it. 8 goes into it 60 times. 480, 9 doesn't go into it. 10 is 10 and 48. Then 11 doesn't go into it. 12 goes into it. 480 divided by 12 is 40. 480 divided by 11, no. Well, we did 12, no. 11, no. 12, yes. 13, no. 14, 480 divided by 14. 480, let me do that again, divided by 14. It is not an even number. I know 15 will go into it, is 32. 15 and 32. Oopsie, not 36. 32. And then the last one, 16, goes into 480 30 times. So this right here, 16 is my largest perfect square. But as you can see, I've kind of got a systematic approach, and I'm finding the largest perfect square. And I don't think there's going to be a larger one than 16, because after that is 25, and I know 25 doesn't go into 480. So I know that the square root of 480 is going to be, right, so this is the square root of 480 ends up being root 16 times root 30, and then this is 4 root 30. So the square root of 30, there's no perfect squares. So this will simplify to 4 square root 30 divided by 24, plus or minus, and then 4 goes into 24 how many times? So x equals plus or minus the square root of 30, and 4 goes into 24 6 times. All right, now I'm just looking at my problem, and in abbreviating my work, I forgot something really, really important, because here I'm looking at the answer, right? It's I. How come I didn't get I in my answer? Well, this is negative. So what is this underneath here? This is negative, right? And so this is going to be, we can put this negative anywhere we want, but this is going to be negative. I always like to put it out by itself. So negative 1, square root 16, and then the square root of 30. So this is going to be I, this is going to be 4, and can we simplify the square root of 30? No. So then my answer is going to be 4I root 30. So right in here, I've made a mistake. So let me just redo that work. And so then we get x equals plus or minus 4I root 30 divided by 24. And then the 4 goes into the 24, so then we're gonna get x equals plus or minus I square root 30 divided by 6. Now I have the right answer. Okay, so you really have to watch out when you're using the quadratic formula, because it's just easy to lose things. I mean, obviously when I look back at my answer, I can see that minus sign, and it's easy to lose. So you want to be careful and kind of double check your work. There was a lot going on in this problem. We didn't have an x term. We were dealing with some really large numbers. We had to simplify a very large square root. And then we had negative under the square root, so then we had imaginary numbers. So again, lots going on. You just got to be careful. Always kind of double check your work and compare your answers with other people to kind of see if you're getting this, the same answer. If you get something different, what'd you do? What'd they do? Because I clearly know how to do this problem, but I made a mistake, and I think it's a mistake that pretty much anybody can make, so you have to be careful.